Okay, so after sorting out the crystal oscillator issue, I thought I'd better go through and check all the actual frequencies now I can actually control it properly. And I've discovered that it's got some issues. There's a lot of frequencies that don't work, or they're 10 megahertz out or 20 megahertz out. The listing did say it was off frequency, but I didn't realise it's quite this bad. Some frequencies are okay. Sometimes a frequency will be okay depending on whether you've gone down or up to that frequency. So if you're, say, stepping through in 1 megahertz steps or something, using the cursor on the frequency display, if you go down it will fail. You go up to it, it's okay. So it's like there's some kind of IC latching fault or something. Possibly a VCO lock or something like that, which is wrong. I don't know. So I've gone notes through the entire frequency range. I did start at about 400 actually, but then I realised that something's wrong. Excuse me. It's 2 o'clock in the morning. I should really be going to bed. Right. I've been playing with this a couple of hours. So yeah, there's a lot wrong with it. So I'm going to have to look at the manual tomorrow and go through the theory of operation and see if I can detect anything which matches what I've discovered here, and hopefully I can get the thing to actually work. Because it'd be a bit of a shame after putting that effort into getting the crystal oscillator to work and to find I can't actually control the frequencies properly. So, oh well, we'll see how we go. Right, so I'm trying to diagnose these problems with the frequencies being out by 10 or 20 megahertz. I'll start with that bit. It's got a few problems. Measuring the VCO input over here, which you might not be able to see. Voltage here, frequency there. So the frequencies are strictly on the back of the VCO. This is set to 880 megahertz, so it's close. 870 is wrong, it's 20 megahertz out. 860 is 20 megahertz out. 850 is correct. I'll come do voltage measurements. This is on the control voltage for the VCO. So if I do relative measurements, you can actually see the steps differently. So 850, which works. Now it's about 300 millivolts per 10 megahertz step. 860 is 300, see? If I do relative again from that one. 870, which doesn't work, has gone up 900, which is like 3 steps, which just makes it 20 megahertz out. So the control voltage is out by that much. I go up one more, 880, which also doesn't work. 880 does work, sorry. 880 does work, so that's correct for 880. And that there would be wrong. So that's 890. So I think that's going to be doing 910. There you go, 910. So the control voltages are what is causing that problem. It's not the VCO fault, it's the control voltage fault. So at least I've narrowed it down to half the circuit. Need to keep narrowing it down a bit more. So I'll show you where I was actually measuring. A bit closer now. So this is the VCO circuit here, it's on the bottom of the board. The control voltage input is there. VCO output I'm measuring is over here. That junction of that resistor and that coax. That's the VCO output. So the control voltage is what's incorrect. So I need to trace backwards from that point. Okay, let's go through the alignment procedure. I've already done some of it. Let's try to use it as a diagnostic tool to figure out what else is going on. I did find that one of the VCO adjustments was out a little bit. I suppose I set for 530 megahertz top end, and that was almost 540 it was actually set to, because of obviously aging and stuff. So I adjusted that. I don't know if that's actually helped anything, but what I'm just doing now is this stage here where that 10 megahertz internal crystal is adjusted in order to get the correct PRL lock in the 10 megahertz section. And this is the bit I'm going through right now, which is page 148 of 312. Yeah. It doesn't actually seem to work. So what I've done is I've connected up as it's got here. Connected up my signal. I've got my Marconi signal generator inputting 10 megahertz to my oscilloscope and stuff like that. So because that's adjustable, and that's oven controlled anyway, so it's close enough. It's not perfect, but it's close enough. I'm going through this procedure here. That's okay, but it mentions about the signals being locked, right? So you've got you're viewing the two waveforms, and it should lock together, so they're in the same frequency domain, or at least matching frequencies. But that's not actually happening. I'm doing this adjustment. The adjustment itself is working, but if I adjust, it's not working. So it looks like this PRL section here isn't actually adjusting. I'll show you what I mean on the scope. Give me a second. Come here. Right, so I've got some bother dodgy leads. So the grey lead is from my signal generator. This lead here is going around the back to the reference input. So the signal generator is providing reference for this. That's set for external reference. The 10 megahertz output is fed back into channel 2 as per the service manual. So you can see they're not locked. If I adjust it here, it'll shift frequency, right? But it's not actually locking, it's drifting up and down based on the adjustment I'm doing. Right? So I'm adjusting up and down. They're not locking frequency. And this is part of a PRL system, so it should actually lock on frequency. Which means that this VCO in here, this is the adjustment in here. I've got that capacitor there before thinking I needed it. I'll just lift it one end just to disconnect it. So this is what controls the circuit here, this IC. I'm concerned that something is wrong in here, because based on the manual it should be locking frequency, then unlock again when you reach a certain adjustment, and that's not happening. So I'm going to have to look in this section really closely to figure out how the hell this bit works, because this doesn't appear to be working correctly. Okay, I've made a little bit of progress with this. It seems to be working at the higher frequencies now, whereas before it wasn't working at all. Which might have been due to this adjustment I had to make over here for the PRL VCO. Right now I'm just looking at this. I've got it set at 470 meg, and it's showing uncal. Now when I push the status button, it shows as 010, which is a main or reference PRL unlock condition, and that's the frequency I'm getting. So it actually shows that yes, the PRL is unlocked. So I'll need to trace that one down. Yes, that's always a bit interesting. So I need to figure out which part is causing that, and I'm going to keep looking, see what other errors I can get on status messages, help narrow it down. So I'm just going through this reference circuit check, and this appears to be faulty. It says that TP57 voltage change when adjusting R to 30, and it should be between 4 and 6 volts. I'm getting 12 volts constantly, 12.3 volts constant, not changing, which goes in line with what I saw before with the frequency not actually being locked, it's just drifting with the adjustment, which may also explain why the need appeared to be there for adding the extra capacitor, because it's over tuning it to the right frequency. So it's probably that it's got a full voltage going there and it's not actually being controlled at the range it should be, which means it's going to be off frequency. What else is there? The other thing I found is I've got the crystal oscillator option there, the ovenized one, and I should be able to see that signal at U68 pin 3, and I can't. There's nothing there. And as far as this bit goes, U69 pin 6. That's there, but it's also the same voltage I'm getting up to TP57. So I wonder if there's a short somewhere or something blown, which is dragging the two together. So because I know it's not working, and I just constant voltage here is pointless. So I need to look into this more. But yes, so I'm going to have to concentrate on this reference circuit before going anywhere else. Okay, so I've printed out the circuit diagrams for this thing to make it easy to look on the computer. And tracing through the RF, so you've got the OCXO comes in here, goes through that device, which buffers it, comes through, goes to this switching NAND gate here. Over here we've got the reference input, so if you've got a reference coming from the outside with the switch on the back, turned on to external, then it will come through here, goes to this device here, which is another switching thing, comes back out through to that NAND gate. So you should have 10 MHz on either of those pins, depending whether you've got input or internal or external reference going on. Then you should get 10 MHz coming out of this one, and I'm not getting that. So if I just probe on, probe in here. So if I probe, which was that? That was pin 5 of U54, so it's that pin there. There's the 10 MHz from the OCXO. If I go to pin 4, come on, get on there, don't slip off. Pin 4. Nothing there unless I turn the switch on. I'm feeding in an external reference. There you go, there's the external reference coming through. Right, so they're both there. If I go to pin 6, which is the output, there's nothing there. So I'll switch back on. So that's back onto internal reference. Still nothing there. So it looks like this device might not be working because it's not passing through it. It's either that or the where are we here? So see that there's nothing on the output there. So either that has got an output or this is shorted. I'm going to have to try and figure out which is which case it is. I might just do like a ground check on the pin 3 and see if there's appears to be a problem there or not, and go from there. Alright, so what I've just done is I've just piggybacked another chip on top of this one, which I think is faulty. So that's U54, which is 74S00. I have a 74LS00P, which is close enough, basically the same device. And I've piggybacked that on top. If I probe pin 6 before, I had nothing at all. Now we have a signal. So that device is blown. That might help improve the situation somewhat. Okay, I've taken the pot out because it's such a pain to get this board out, because it is a major mission. What I've done is I've just cut the pins off, as I always do anyway on ICs, and desoldered it from the top, pin by pin. It's a bit messy right now, it's a bit of a clean up, but what I've got to do is actually solder this chip back in from the top. Now I normally put in a socket, but if I put a socket in I can't actually get to the pins to solder them, so I'm going to have to not put a socket in, I'm going to have to just go straight to a chip. I don't like to do that in case of another failure, but I've got no choice in this case, unless I want to pull the whole board out. Okay, the chip is installed. Again, we've got to clean it yet. See? So if I now measure pin 6, here we go. Signal. Right, so that's that issue resolved. So that's 2 issues fixed so far, and it's still not fixed yet. We'll keep going. Also, after replacing that IC, I've noticed that when I test the voltage here for the POL that's there, it's now correct. Well, close to it. It should be between 4 and 6. So I'll go back to the calibration section for this piece and try calibrating it now, because before I wasn't actually getting a voltage there. I was getting 12 volts constantly. So changing the IC seems to have helped that as well, because it's probably a missing signal. Okay, so we're getting there.